Hello and welcome to part 6 of Getting Started with SQL. This episode is going to be broken up into 3 distinct parts. First, we're going to cover the pros and cons of SQLite and Postgres. Then we'll look at a range of options for getting you set up with your own instance. Finally, I'll set up my preferred choice, walking you through how I would do so. Then in the next entry into this series, we'll use this database to set up our web store again. If you're not interested in the pros and cons, you can skip this first part. Timestamps will be in the description. But I think it's important to have the context as to why we would use one over the other, and it should help serve for a better understanding when you're planning and building databases in the future. This is less for the purposes of writing SQL, more to help you realise when and why one might reach for a different tool to achieve a specific outcome. Getting the tools right at the start prevents potential costly rewrite and re-implementation in the future. So part 1, pros and cons. To be completely clear, this is not an I prefer one over the other kind of comparison, nor is it meant to lead into a definitive conclusion that anyone using either option is wrong. The two both implement the SQL standard, the two are both incredibly capable databases, but both are intended to be used for different purposes. Can you stretch either one of them to fit the other's use case? Probably. Should you? Maybe, maybe not. It's all down to the requirements of what you're building. When I first started this series, I set out quite the case for SQLite. It's one of, if not the, most widely used type of database in use today, and if you're coming into SQL looking for perhaps job opportunities down the line or a career, that's all you really want to hear, right? Well, it's a bit more complicated than that. SQLite is widely used because it's simple, lightweight, and is, well, a file. Creating a new database is as much work as it would be to create a new text file or saving a picture you just downloaded. Comparatively, other database engines are much, much more convoluted, and whilst you can streamline their setup, it's apples and oranges compared to SQLite. SQLite is a file, and that's it. Postgres is server-based, capable of scaling to millions of transactions every second with robust backup and failover options, everything a company needs for a modern application. Gone are the days where downtime is acceptable. Uptime is measured to fractions of a percent. Applications are globally available with runtimes, resources and data stored at the edge, minimizing the round-trip time for a user to fetch a page, whether they be in Tokyo, Miami or Frankfurt. SQLite is great, but with its comparatively primitive single file for storage, whilst you, on your own machine, will likely never hit its limits, a high-traffic production workload will need a lot of optimization. Postgres makes that optimization easier. It not only scales well, but it introduces a whole host of other nice-to-haves, meaning you can achieve the outcomes you want faster. So let's specifically focus in on SQLite, Postgres, and what's different. First is architecture. To understand the differences between a file-based, SQLite, and client-server model, Postgres, we need to understand how we, as a developer, talk to databases. For both SQLite and Postgres, we communicate through a driver. SQLite's concept is then fairly simple. The driver, combined with the file, is the database in its entirety. The driver looks at the file you're pointing it to, opens it up, reads or modifies it in some way, returns your result, and then closes. Job done. For Postgres, you will also use a driver. However, rather than giving it a file path, it takes a connection string in your instruction. The driver then passes this query over to the Postgres server. The server is an application in its own right, in charge of its own memory, handling security, and capable of juggling thousands of other requests simultaneously. It processes the query accordingly and returns you a result. In theory, the server doesn't have to be remote. It can be running on your local machine, as we'll get to later, but it is an important distinction that the server is an application which requires installation, setup, and to be running when you pass a query to it. So on the one hand, we have a file which is opened and interacted with via a driver. On the other, we're communicating with a whole application which is receiving our commands and handling them within its own system. Both SQL, just two different implementations. Second is concurrency. SQLite is restricted to one writer at any one time per database file. Up front, this might sound quite restrictive, but when you come to realise that most write transactions will take a couple of milliseconds at most, you're going to have to really increase the number of writers before you hit an issue. Conversely, Postgres can handle thousands of simultaneous readers and writers. Sure, row and table locks can still happen, but the strict limitation of one writer at a time is gone. 3. Data types. SQLite data types make up the foundational building blocks for what Postgres has really. Text, integer, real, and for everything else that doesn't quite fit, we can always revert to blob. Postgres has those, but more. JSON support, arrays, and universally unique identifiers for when an integer key just isn't the right choice. And if you can't find the right type in Postgres defaults, you can even create your own. 4. Scale. This is really the deciding factor as to when you would choose SQLite versus anything else. If you want a small database for holding a limited amount of data, SQLite is a no-brainer. On-device apps, prototyping, and pretty much any scenario where you don't want to be setting up and maintaining data infrastructure, SQLite is perfect. Postgres isn't so simple in setup, but boy can it scale. With some configuration, it can easily be ready to handle enterprise-grade, gargantuan production web apps with millions of users. You can achieve a lot with SQLite. So far in this series, we've barely scratched the surface. Don't believe me? I'd highly encourage you to check out projects like Pocketbase, an open source backend in a file based entirely around SQLite. Or Blue Sky, another open source project, a decentralized microblogging alternative to X. It uses a SQLite per user for its personal data service, or PDS. SQLite's easy to set up and tear down nature fits the use case perfectly. All of the code for both is available and on GitHub for you to read. They're a million miles from our 4-table web store example, but they are real-world examples of where SQLite is being used incredibly effectively. But though a number of notable exceptions exist, and no doubt more will continue to pop up as the years roll by, the fact of the matter is most SQLite implementations are small, on-device instances. 95% of the code you write for SQLite will work in Postgres, but not vice versa. Postgres, other engines are of course available, has so much more to explore and understand, and in reality is what is going to get you an experience more akin to what you would be dealing with in a professional setting. So with that said, let's have a look at how we can set up a Postgres instance. In order to use Postgres, we need to set up the server part somewhere. You could go ahead and install it on your local machine, but there are other, potentially more preferable options that are worth exploring. For starters, Postgres isn't really something you just install. There are a ton of configuration options, and Postgres itself, designed to be an always-on, constantly available service, will happily consume as many system resources as you allow it to. There's nothing wrong, per se, with installing it directly onto your personal machine, but there is in here a word of caution. If you're going for that option, limit how much of your system it can use. With that said, I'm now going to present 4 or 5 alternate ways you could get set up with your own instance. First is Docker or Podman. If you absolutely need a local install, containerizing the install is a really great option. It can be started, paused, stopped, and destroyed at will. There are standard Docker compose files which should get it up and running in the time it takes to download the application and run the setup script. If you have Docker or Podman installed already, this is likely a really good option for you. Second, you could use a separate piece of hardware. This option is for those who like to hold on to their old electronics or perhaps have a Raspberry Pi laying around. A Postgres install can breathe new life into older, less capable machines. Third, and not without incurring some cost and requiring a pinch extra care for security, utilize the cloud, an option I personally use myself. I host a Postgres server on its own VPS, and if you feel comfortable configuring and setting up one of these, even a small cloud VPS can be a great option for a personal Postgres database. Whilst all of these are good though, they still involve a lot of setup. We're here to learn SQL. Database administration is a whole other discipline. The default options are likely fine to get you started out, but when something goes wrong, the last thing you want to be doing is spending your time trying to work out why your database corrupted and if you can even get your data back. Instead, I'm going to present you with 2 more similar services which at time of recording will give you a small, free, cloud-based Postgres instance. First is Supabase. Marketed as a backend as a service, Supabase is built entirely around Postgres. Its capabilities go far beyond what that of a standard Postgres install would give you by default, but at its core it is just Postgres. Create an account, set up a project, grab your connection string, and you can have a free 500 megabyte database to play with. The catch here is, unless you're on a paid plan, these are paused after 1 week of inactivity, and at time of recording deleted after 90 days. Restoring them before the 90 days is up is as simple as going into your control panel and restoring the project, but it is something to consider when weighing up the options. Second, and my preferred option for this series, is Neon. Neon offers something a little different. It's another database as a service-like offering. The free account gives the same 500 megabytes of storage per project, and you can have up to 100 projects. But the next part is where it differs. They have separated out the two elements of storage and compute. The compute, or thinking part of the Postgres server, is configured to stop and start as needed. No activity for 15 minutes, it shuts down. Send a query 30 minutes later, and it's back up and running, normally in less than a second. Both Neon and Supabase haven't paid me to say this. They will obviously need an internet connection anytime you want to interact with them, but provided you don't plug a credit card in, they will otherwise cost you nothing. They will hard cap you at 500 megabytes of storage though, and that can be limiting for anything more than the smaller project. Hit that cap, and I would advise you're better off going with something local before forking out for premium cloud-based options. We won't get close to exceeding it in our tutorial though. So having presented all of these, it's now time to make your decision. For this series, I will be using Neon. It's simple, free, and will easily encompass this tutorial and then some. I could sit here and muddle my way through a Postgres install on screen for you all, but with so many operating systems out there, future upgrades which may well alter the install process, and many creators already making how to install Postgres on X videos, I'll leave this option for those of you who hold the initiative to get started that way by themselves. Regardless of what option you choose to continue with, the only two things you will need are for your machine to be able to talk to a Postgres server, and the connection details for said server. So if you're joining me on Neon, go ahead and sign up for their service. Otherwise, we can meet back up when we're connected to the Postgres database in DBeaver. First off, we're going to head over to neon.com. I already have an account, so I'll log in. It's been a while since I went through the setup process, but there should be no need to put in any credit card details as you're getting started. Just make sure to select the free plan. Next, from your dashboard, we're going to go ahead and create a new project. Give your project a name. Select the version. I will be using 17 for this tutorial, but you won't be missing out on anything if you choose a higher version in the future. Finally, select a region. Select the closest to you geographically. It won't matter too much, but it does mean that the data has less far to go when you're sending queries to it. I'm based in the UK, so London is an obvious choice for me. I'll skip the Neon Auth option and go ahead and hit create. In less than a second, in my case, it's provisioned a Postgres database for us in the cloud. We'll go ahead and click connect and change connection string to parameters only. Unfortunately, I'm going to have to blur quite a little bit of this out, but we're going to want these connection details for DBeaver to be able to connect to our database. In DBeaver, we'll select Database, New Database Connection, and select Postgres from the available types, and click Next. Then, switching between our Neon dashboard and DBeaver, we're going to enter the host, database, username, and password. The port can be left exactly as it is. Be sure to select Show All Databases. Side note, depending on what option you pick, this may be where your experience will differ. If you're using a local install, you may want to keep localhost and the port you configured, the default being 5432. Alternatively, if you're repurposing some old hardware or going with the cloud-based VPS option, you'll either need the IP address or the host name of the machine that you need to connect to. Again, make sure you use the username and password you specified during the install, and you should be good to carry on. Now we're going to go ahead and hit Test Connection. If it's your first time doing so, it will prompt you to download a driver that we spoke about in part 1. In my case, there's a success message. If you don't see this, it means that it's been unable to connect to your remote Postgres instance successfully. Were that the case, go ahead and check your connection details again before trying Test Connection. Finally, I will hit Finish, and a new database will appear on the left-hand side. Much like with SQLite, we can expand this out. Go to Databases, and there is our NeonDB database. The layout differs slightly from SQLite in that Postgres will break things down to schemas, our public schema, and then within here we have tables. Don't worry, I'll show you how to navigate all of this in the next episode of this series. Thank you for following through with me to this point. That concludes this very different but important video as we transition from using SQLite to Postgres. Hopefully all of the yapping made it clear as to why we're going to something different. If you're still unsure, stick with me. In the coming videos, I'll be able to show exactly how powerful Postgres really is. Comments, questions, or just how you're enjoying this series, let me know in the comments. I'll see you in part 7.